Assalamu alaikum students. Today we are going to discuss about the work energy power topical questions, paper number 4, theory paper. So I believe that the videos I have sent to you, if you people have gone through those videos, you will have no issue about the paper questions. I mean, while solving these questions, I will solve this and I will send you these notes as well. Uh, I will send the link of these notes to you. So let's talk about this question. This is a worksheet which is basically the worksheet section is 1.12, 1.12, and in that one we are talking about the work energy, power efficiency, and transfer of energy, or you can say forms of energies or energy resources and all that stuff. So here, question number 1 that shows that electrical powered bicycle, this is basically the electrically powered bicycle is there, and when fully charged by the battery can deliver a power of 600 watt for 60 minutes. Calculate the energy in joules stored in the battery when it is fully charged. So for this question, you have this clue what I have highlighted for you. You must now the energy formula, that energy is equals to power into time, or by using the triangular formula you can say that power is equal to energy divided by time. So here energy is equals to 600 times 60 minutes. So 60 minutes will be converted into 6 seconds. So I will convert it into 60. So it will give you calculation. Let me just open up my calculator and I'm going to calculate that stuff. So it will give you a reasonable number, and you have to use that into a suitable significant figure. So it is 600 times 60 times 60. So actually the number I got, that is 2160,000 joules. But for number of significant figures, or by the consideration of significant figures, we will use the answer till 2 to 3 significant figures, because here these significant figures are 2. So you will say that it will be 2.16 into 10 raised power 6 joules, right? Or finally, the answer you will write, it is 2.2, because I will round this up and I will increase it by 1. It will be 10 power 6 joules. So 2.2 into 10 is power 6 joule is the total energy provided by that battery when it is full charge. So the next question is, state the form of energy stored in the battery. So what form of energy do you consider? In the battery, basically the batteries use chemical energy. So it uses chemical energy, right? You will score 1 mark here. And then the next mark is, the bicycle has a motor with electrical input of 250 watt. It is your power input, okay? And then calculate the time for which the battery can power the bicycle, okay? Calculate the time for which the battery can power the bicycle. So here again, check that here you were using your formula one first time. So you were having 3 marks. 1 mark was for your formula, 1 for values placing, and 1 for your answer A mark. But right here you have 2 marks. 2 marks means 1 mark will be for your, I mean, for formula you will not be awarded any mark because you are using the same formula back. So here we are saying that we have to calculate time. So I will use the same formula, that energy is equals to power into time. So time is basically energy divided by power. So the energy I have calculated that I will use 2.16. I will not use the rounded off value here, divided by 250 watt. Okay, so I can calculate time here. Just let me calculate that number. It is divided by 250. So it takes 8,640 seconds. So 8,640 seconds. Now check this one out, that here you are not having unit, like here you had the unit joules. It means you do not have any choice, but here You have choice. If you want to write the answer in seconds, it's fine. If you want to convert this into hours, then you have to divide it by 3600, and you will say that it is 2.4 hours. So either write this answer or you write 2.4 hours, you will be awarded some hours. Okay, so the next part of that is, consider this bicycle compared to a small motorcycle. State two environmental benefits of the electrical power bicycle. So, electrical power bicycle, one advantage is it has no pollution, right? I mean, in normal bicycle or a UEL bicycle, what happens? There is a petrol or a fossil fuel there. So, in electrical bicycle, we are using electricity, so it has no pollution, right? One thing. Secondly, it is renewable, right? It is using a renewable source. For example, you are going to use it, you are going to charge it. So fossil fuel is not renewable, it will be consumed. That is one of the problems. And third advantage, what I am going to write it as an additional one, that it does not cause heating, right? It does not cause heat in the surrounding, heat to the environment, you can say. Okay, so in this way, you can write any two of these advantages. Okay, the next question is that question related again to the battery. So battery provides energy of the electrical car. So it is the same question. I'm going to just skip it. I will solve any other question which is basically related to, a bit different question. Okay, so let's say this is again, the power station uses a wind energy generated in terms of electricity. So state and explain whether this method of generating electricity is renewable. So yes, because why explanation? Because you have 2 marks here. So 1 mark is for statement and 1 mark is for explanation. So what explanation will you have? That because wind is not consumed, right? Wind is not consumed. So you can solve in this way. Secondly, state two energy resources that do not have sun in their resources. In my notes, I told you typically that this is the question asked to you. You have to mention two resources in which sun is not directly involved. So, what are those two resources? One of them is, I mentioned, that is geothermal energy. Okay, one of them is geothermal energy. Okay. Secondly, you can use nuclear energy in power plants. Nuclear energy in power plants. Okay. Or third option is your tidal energy. So if you have used or if you have gone through my notes or the previous video, it will help you out to identify the issues. Then for each energy resource, state the form of energy stored in fossil fuels. What type of energy is being stored? That is your chemical energy. Okay. And for the next, a battery behind water behind hydroelectric dam. So water has gravitational potential energy. So these are the questions coming from energy resources. And here we go. This is a question related to your mechanical energy. That is figure 2.1. That question is in October number 2021. Right? So, and question number 114 of your worksheet. That figure 2.1 shows a simplified version of the gravity lamp. Okay, this apparatus is used to light emitting diode. That apparatus uses a light emitting diode LED without mains electricity. Okay, without mains electricity. So there is a generator, there is a light, and there is a strap, and there are definitely some sort of load attached. So when the load will move down, I mean, when the load will be released, what will happen? That pulley will rotate, or generator will rotate, and that will produce the electricity. Okay, so with the help of this weight, you are going to produce electricity. So weight possesses gravitational potential energy. So when that will be released, gravitational potential energy will be lost, and loss in gravitational potential energy is converted into kinetic energy. So the load of 12 kg is raised to a height of 1.7 meters, right above the ground. The load is connected to a pulley system. The time taken for the load to fall to the ground is 1200 seconds. The load falls at a constant speed. The generator is connected to LED. Calculate the rate of and transfer of gravitational potential energy as this load falls to the ground. So, as I told you, that here it consists of gravitational potential energy. And when this question is asked to you, that you have to calculate the rate of transfer or rate of energy. So actually examiner means that you have to calculate energy per unit time. That is simply power. So here I'm going to calculate, that is a 4 mark question. So when you are going to collect 4 marks from here, you will write that power or rate is equals to energy divided by time, and energy is basically your mgh divided by time taken, and then finally mass is 12 kg, g is your 9.81, and your height is 1.7, and the time taken is 1200 seconds. So let me calculate that. It is 12 times 9.8 times 1.7, that is divided by 1200. It is 0.166, that is 0.166 joule. So I will write the answer for A mark. What you have to do, you have to see that there are two significant figures all around. So it is also two significant figures. You will write 0.17 joules per second. Its unit will be joules per second. Or you can simply say that is 0.17 watts. So both answers are correct for you. So here you will score 4 marks. The next is the light output of LED is 0.1 watt. What is the output of the LED? Output of the LED is your 0.10 watt. And here is basically that input. This is what you have calculated here. You will use that calculated number. That is your input. Okay, so mind this. This is your input. So just use this as an input. Okay, and that is input power. So this is your output power. Okay, so calculate the efficiency of the gravity lamp. Sorry. So how will you calculate efficiency? Efficiency is equals to useful power, because I told you in my notes and in my video lecture that it is either power ratio or energy ratio. So because you are having powers, input and output, so efficiency will be useful output, because you are having 2 marks. So no need to write formula totally. So it is useful output power divided by total input power, 5, total input power, okay, times 100. So what will you do? Actually, useful output power is 0.1 watt, and input power is 0.166 times 100. So let me calculate that. 0.10 divided by 0.166 times 100. So it is 60.24. So you are getting 60.24%, because here again there is no unit. Okay, so you will write just percentage. So your answer is 60%, right? What is your answer? 60%. Suggest a social or environmental advantage of using the gravity lamp. So, what is the social or environmental advantage? So, it will produce no pollution, it will produce no noise, no heating, and so on. So, it has no pollution, environmental pollution. So, this is a common thing that that is basically the advantage of that. So this is all about that one. The next question is again your gravitational potential energy question. That is figure 3.1 shows the water flowing at very slow speed over the cliff edge, and it is 1.5 meter. The height of the water is 1.5 meter. Then show that the velocity of the water striking the rock is 17 meter per second. Actually, this is again a 4 marks question, and that is related to the interconversion of energy, right? So, all of the energy here that is GPE, and when this water will fell down here, all of its energy will be converted into kinetic energy. So, when kinetic energy, I mean, gravitational potential energy is converted into kinetic energy, you will say that is uh, loss in, because that is 4 mark question, so we have to use this method. Loss in GPE equals to gain in KE. So loss in GP, because you are not having mass. So I have selected this formula because I want to cancel the masses. So it will be equals to 1 by 2 mv square. So from here, your mass will be cancelled out and you need velocity. So velocity square will be equals to 2gh, and just plug in the values. That means that velocity is equals to 2 times 9.8 times height was 15 meter. So just put all these values and take square root. Let me calculate that. 2 times 9.8 times 15, it is 294, and 294 square root is equal to 17.1. So velocity is 17.15, 17.15, which will give you almost 17 meters per second. So you have to show that. That's why answer place is not available. So it's fine. Now the next part of that is 30 kg of the water flows over the cliff edge every second. This is basically rate of water flow. It is simply called mass flow rate. What do we call it? We call it mass flow rate. So how much mass is flowing per second? 30 kg. Calculate the force exerted by the rock on the falling water. Ignore any splashing. So basically, this question is linked from momentum. As I told you, in the dynamics or momentum, we just use, or we have the link of these questions in work energy power. So here, force is equals to delta P divided by T. So mass, change in mass per unit time. Okay. So that is M into V minus U divided by T, because all of the initially water is at considered as rest. So when it is dropped, its initial velocity is 0. So you can simplify this equation, mv divided by T. So I can say that force is equals to mass per unit time is simply here, and you have calculated final speed. So mass is how much? 30 kg per second. So I will just direct write the number 30 here in instead of this mass divided by time into velocity is 17.15. I have calculated that number, and now I am just going to multiply this with 300, sorry, with 30, and I'm getting 514, right? So I'm getting 514 Newton, which is actually equals to, you can write 510 Newton, or if your answer is 500 Newton, that is also correct. So these type of questions are asked to you in your different areas. So I hope that it will be clear. This was just an idea to idea given for you people to solve these questions. In my next video, I will solve further questions from MCQs, and then inshallah it will help you out. See you then, inshallah. Allah Hafiz.